Hey, welcome in CVE engine again. In this video I'm going to explain details of editing the particle systems. I will start with this smoke particle system that is in simulation already. You can move it holding the shift key and dragging it with mouse. The yellow wire represents the pivot of the particle system that I was moving now. The orange wires show the direction and start velocity of the particles. You can change them holding the control key and dragging it with mouse. And the green line represents a line that defines a space from which the particles will be emitted. You can change it holding control and shift key and dragging it with mouse. As you might already know, you can minimize and restore all the blocks of the edit page clicking here, and each block clicking on its caption. So I'm going from up to down. Clicking this button, we can delete all particles that are right now in the particle system. That's useful when you're working with particles that do not disappear, or when you get too many particles, and for more situations when you just need to clean it up. The boom button runs the command that emits a number of particles in one moment. The number of particles is defined here in the emitting block, so I click it and here we can see that the boom count is a random number between 100 and 200. This is the same button to emit the particles. This checkbox can switch off and on emitting of the particles defined by a time. The interval between emitting the next particle is defined here. Again, a random number between this time value and this one. And how many particles are being emitted each time we can set up here. So when I write here 10, then we can see we have 10 times more particles in the particle system. Okay, I set it back to 1 and close this block. Here we can see the number of currently existing particles. It's the number of non-sleeping and sleeping particles. Yes, we can have some particles sleeping. It's a special case of particles that don't move anymore, and so they are faster to process in a physics engine. These two buttons can copy and paste all the parameters of our particle system, so we can copy them from one to another. Here we have a name of the particle system. We define it when we're creating the particle system. I will show that later. Okay, I open the basic properties block. The first parameter here is a texture for the particle system. So we can open the texture library pressing F4 key. Click here on one texture and assign it to this particle system by clicking this button. Now every particle in this particle system is made of this picture. For smoke effect like this, it is quite enough. For another particle system, we might need to define more different pictures for the particles. So I'm going to assign a texture like this one. And here in the multi-texture parameter, I will set up that there are 4 by 2 pictures inside, and now each particle will be made of one of these 8 boulders inside one picture. To cancel multi-texture, we simply press this button and assign different texture. Each particles have a color parameter. For a particle, a random color between these two colors is generated. Just click on the color to change it. The color consists of classic red, green, blue channels and for particles often important alpha channel. Particle can change its colors in its lifetime, and the same way it can change the alpha value, so it can fade in and fade out. I will show that here a little later. So we keep going through the particle system parameters from up to down. The next parameter here is blend mode. There is a number of these modes. They all blend the colors and alpha channel in a different way. The color result depends on the mode, particle color, and alpha, and texture pixels, color and alpha. That's all adjusted also with this color operation parameter that can make it lighter. Position is the pivot of the particle system that I've been talking about already. We can move it here with mouse, and we can set its coordinates with exact numbers here. I was also talking about the line parameter that is drawn by the green line in wires. Here we can set up its coordinates in numbers too. I will show here a little later how it defines the space of emitting the particles. Okay, start speed defines the speed of the particle when it is emitted. It is a part of start velocity vector that also contains a direction of the particle way. It is good to have the velocity vector divided to speed and the direction for more reasons. For example, when we are scripting and changing the particle system, and we only want to change speed of the particles without changing the direction. This start speed multiplier just multiplies the start speed of the particle when it is emitted. It multiplies the speed with a random number in this range. So this means that the start speed of the particle will be generated randomly from 20 to 40. The start direction is the angle of the particle start velocity. The scattering parameter represents an angle of diffusion of the particles. We can see that the angle is drawn here. Size on emit defines how big the particle will be when it is emitted. This means that its size will be randomly generated in this range from 1 to 10. Particle weight is a real weight of the particle, so when it interacts with some object, for example when it bounces off an object, then its response is calculated according to its current velocity and its weight. So far all the particles have the same weight. If we will need different weight for each particle, it won't be a problem to update. The recoil effect is an interesting and useful effect that the emitted particle does on object to which the particle system is linked. I'm going to select this particle system that is linked to the spider head. I switch the emitting on and increment the recoil effect power. So we can see that the recoil effect does the push like a jet. The recoil push effect depends on particle start velocity, particle weight, and the number of particles emitted in time according to the object's weight and the point of link. Okay, let's go to the next controls. This checkbox sets up whether the particles will bounce off the terrain or not. When unchecked, then the particles will fly through the terrain. The same way, the next checkbox controls whether the particles will bounce off dynamic objects or they will fly through when unchecked. When this don't bounce off linked robot checkbox is checked, then the particles will not bounce off any object that is currently a part of robot to which the particle system is linked. That is useful, for example, for the soldier jet, so its particles don't collide with any part of soldier's body. This parameter, disappear after first bounce, is useful mostly for the bullet's particles. So as soon as the particle collides with some object and does the collision response, it disappears. Do bullet deformation parameter means that when a particle hits some dynamic objects, then it does a little deformation on it. The power of the deformation can be adjusted here. You can see this bullet deformation when shooting with the soldier to the dynamic objects. When particle sleeping is allowed, then the particles that fell on the ground and they stopped moving, they switch to the sleeping mode, and then much less calculations is needed to perform their physics. We use this, for example, for the shard particles. It will be a lot of these shards when shooting, so these shards on the ground switch to sleeping. Okay, there are 3 rotation styles of the particles, and we can add some more if needed. The rotation style says how the particle will rotate or will be rotated when it moves. By move and like a rolling stone are similar styles that rotate the particles the way like they are little rocks. We can see it here on these rocks falling. They rotate as they fly. Like a bullet means that the particle will be always rotated in the direction it moves. I will show that on the particle that the soldier can shoot. So I pause the simulation, select this particle system, emit one particle clicking the boom button. I move forward the simulation by a number of frames, pressing the O key, and here you can see the particle. The front and the pivot of the particle is here, and it's at the top of the particle texture and center of the texture width. As I said, we can add more these styles when needed. Okay, let's go to the next control. This control is disabled so far, but will be working fully later. When checked, then the particle system will be deleted from the simulation completely as soon as it doesn't contain any more particles. That is useful, for example, for the explosions. So as soon as all the particles of the explosion disappear, then the particle system will be removed from the system. The emitting block contains the parameters that affect emitting the particles by time and emitting a number of particles in one moment that I've been talking about already. Here we get to a definition of a space where the particles will be emitted. That depends on the green line of the particle system. I'm going to adjust this particle system a little so I can better show you this parameter. Just a moment. So we can see that the particles can be emitted from the pivot of the particle system. When I select the line here, then the particles are being emitted from the line. When I select the line points, then the particles are being emitted from the beginning and ending points of the line. When I select line endpoint, then we're emitting from the ending point of the line. When I select a rectangle, then we're emitting in a rectangle whose diagonal is represented by the line. This might be, for example, useful to create stars on the sky in the background. When I select the circle, then we're emitting on a circle whose center is the particle system pivot, and the radius is represented by the line. When I select the wheel, then we're emitting the particles inside this circle. And the next three parameters are not working so far, but they will be responsible to emit the particles in a space of linked object mesh, border, or its pivot. Okay, the next block contains several players. The players affect particle parameters in a lifetime. As until now, also these players can be combined, so each player affects the particles independently. So let's start with the first one, that is sizing. We can switch on and off each player. So I switch on the sizing, and then the size of particles can grow or lessen depending on positive or negative numbers here. For each particle, the sizing parameter is generated as a random number in this range. So when I set it up this way, then the particles will grow by 10 to 20. When I set here the negative numbers, then the particles will lessen. As soon as the particle reaches zero size, it is deleted from the particle system, or as I say, it disappears. The vector gravity defines the gravity for the particles. For the smoke, you can see I have used the gravity with direction up and the smaller acceleration. So we can define here the vector that will mean a direction and the power of the gravity for the particles. Or we can just click this checkbox so the particles are affected by the same gravity as it is set up for our scene, our world of physics. Okay, I switch the gravity off and open the gravity to point block. This type of gravity works like a magnet. We can set up a point where the gravity will direct for each particle, and we can set up the power of the gravity. So far we can edit these parameters only by the numbers. That's not very handy. Might be a thing to update too, but so far this is a special parameter, mostly meant to be controlled by a script. We can set a negative gravity power that will have opposite direction effect on particles. The fade alpha player is useful to fade in and fade out alpha channel of particles. When the fade in parameter is 0, then the particle doesn't fade in. When the fade in speed parameter is set up, then the particle alpha grows until its maximum. After that, if the fade out speed parameter is set up, then the particle alpha fades to 0 and then it disappears. We can also only fade in the particles easily, setting the fade out parameters to 0. The maximum value of particle alpha is 255 and the speed of fading it is per second. So when we have here, for example, 25, then it fully fades in about 10 seconds. You can see that for the smoke there is a startup alpha about 25 and then it only fades out about a second. Air friction is a parameter that can slow down the particles flying in the air. For each particle, a random number in this range is generated for its air friction coefficient. Angle tracker is an interesting parameter with which we can make particles fly like in a wave, in a spiral, or fall like a leaf. We can set up how much this affects particle angle of its velocity, and we can set up where in the path of angle changes it will start. With the angle tracker set up to these values, it is easy to make the smoke particles a little waving. The color blink player is useful to change particles' color in their lifetime. The time interval of fading from one color to another is defined here, again by a random interval between two numbers. We can set up two colors for this player. Here only red, green and blue channels are in effect. Alpha is not. And with these two checkboxes, we can set if we only fade between these two colors, or we can set that the first or the second color is being generated randomly in the range of these two colors. This color blinking player can be useful, for example, for the stars, so we can set them a little blinking. The alpha blink is the same as the color blink, but it only affects alpha channel and does not affect the color. You might ask why this is not a part of color blinking player. Well, we might want to have some particles a little blinking while they fade out alpha channel to 0. Well, this is all about the particle players. We can add some more if needed, or just post an idea. The next two blocks are about how the particle system is linked to object and to robot. So I select one particle system that is linked. We can see here that it is linked to an object with name head. We can see here a local link point. So I will change it a little so you can see I have moved it to a different place on the spider head. We can change also the direction of the particle system here. Here you can see that the particle system is about to move and rotate together with the object to which it is linked. So when I, for example, switch off this rotating with linked object, then we can see that the particle system will only point to one direction, even when I rotate the spider head. And when I switch the rotating with the linked object, then it rotates together with the spider head. Here I have to tell an important thing, and that is that I was editing the particle systems that already have been in our simulation. And that is good when we just want to try to change the parameters and see the result immediately on the run. We cannot save particle system that is already in a simulation. You know, some of its parameters are being changed by a script or by another influences. We somehow need to create a new particle system that is not being played in a simulation. Then we can copy all of these particle system parameters and paste them to the one that we've created out of the simulation. Then we can change its parameters additionally and save such a particle system. The question is here how to do that. The only way, and for many reasons a good way, is this. I go to create a new robot. A robot doesn't have to contain objects and joints. It can contain particle systems only. So I go to the robot editor and I click this button to start making a new robot. The robot can contain objects, joints and particle systems. I click here to edit particle systems of the robot. I click here to open particles block. I click here to add new particle system to the robot. I will write a name for it here. I could write the name of an object to which the particle system will be linked, but now we'll do it without linking to an object. I can set up some more basic parameters like position, direction and layer index here. And here I will click this button, so I go to the particle system page, and now you can see the difference. I am editing now the particle system that is not in our simulation. It is a part of robot that we are editing. Once more, I will select some particle system that is already in a simulation now, so you can see that the robot builder window disappeared. I have selected this particle system because I want to copy all its parameters, so I click this button so the engine copies the parameter values of this particle system as they are right now. I return back to the robot builder editor and I select our new particle system and click the button to edit it. Yeah, so we are back in the particle system editor and we have selected the particle system that is not in a simulation, but it is a part of the robot that we're building. And now I click this button to paste here the particle system parameters that I have copied before. I go back to robot editor and I might want to save this robot. You can see that the button is disabled. The reason is simple and about to remember. We have to write a name for our robot. The name of the robot is also its file name. That also helps us to have unique names for the robots. So I write here smoke 2 and then I click the button to save the robot. The robot is saved with all its parameters, all its objects, joints, particle systems and all their parameters. You might want to ask for the reasons why the objects and joints and the particle systems need to be saved inside the robot. Well, there are many good reasons. We will need to control a lot of things of the particle system in a game. For example, we create a laser particle system that will switch off when some friendly soldiers come nearby, and this laser could switch on when an enemy soldier comes nearby. This is what we can control in a script on update of the robot. So we write there at some place, you know, the robot, get particles by name, switch on emitting or switch off emitting, and so on. Another example is that we might want to make the smoke with two different particle systems and move them together, and later we might add one more particle system that will emit, for example, sparks from the smoke, and these sparks can interact with object different way than a smoke, but still we want to move and control them all together in one script. And here I want to tell another important thing. All the parameters that we can change here in editor, we can control in a script of robot. So there is already a nice number of things that we can change and control in a script. So this way we can switch on and off the jets, do the shootings and much more. I might mention now that we can find all robots in our robot library. We can open it pressing F8 key. To load a robot, simply click on it and then click the load button. One more useful information here might be that when we are in the robot edit page, we can put mouse cursor here to the simulation and press the insert key to add a robot to a simulation. So we can try, for example, to walk with our robot or change its parameters on the run and so on, you know. As soon as we reset the scene, this robot disappears because we define robots and other things for the scene here in the scenario page. Well, I think that's all from this additional information for now. Don't forget that each control has a hint where you can read more about the parameters. And there is a help window when you press F1 key where you can see all the shortcuts and function keys for editing. So if you're gonna try it, have fun and write us a reply. Okay, bye.